Yes, that too.
All right, everyone, let's get started. We have a little bit of a small class today, but that's all good. As regardless, I personally think this is like the best, most exciting part of the class when we teach you how to plot and we teach you how to use pandas. So today we're doing data with NumPy and pandas.
Awesome. Next slide.
Before we get started, a couple of quick announcements. Please make sure that before you head off for spring break, you talk to your mentors for your final project check-ins. I think the actual assignments due like April 1st at midnight, but some of your mentors might not have office hours before that Tuesday. So make sure you're in communication with them and check in with them. Even if you don't get your actual check-in done, please go to their office hours, talk to them. We're all here to help. And also the earlier you get this done, the less you have to stress over spring break. Don't spend your spring break working on Python. Okay. Try to get it out of the way before you leave. So do that. Homework 7, I believe, is due tonight, and homework 8 is being dropped. Yeah.
Okay, so just for a little recap, I believe you guys, I wasn't here, but I think you guys went over NumPy and things like that. We're going to use a little bit of that today. And as you know, NumPy is like one of our go-to packages to do a lot of stuff. They can do array stuff, make it faster than actual normal Python arrays. They have inbuilt stats functions. I don't think we're going to cover that today, but just know that it exists. And then all the stuff like data structures and functions and loops that we've already covered previously. Is going to help us take a lot of data and process it. So that's what we're going to do today.
Cool. A lot of the data, if you've seen much data in this class, has been like nice little arrays or nice little lists that are like in increasing order and sorted very well. But data in the real world, as you guys will start to see when you start looking for data sets for your final project, is very different. There's a lot of data. It's usually very, very messy, and half the time it doesn't contain the exact information you need in the form that you need it. The reason behind this is usually when you're collecting data, it comes from real-time observations, especially scientific data, which are often prone to errors and fluctuation. There's always problems like missing data points. There might be a weird structure. There might be like different units that you need, and it might not be standardized. There's just so many things that are typically happening when you look at real, true, raw data. This is an example of data that I work with. As you can see, it really doesn't make any sense in the form that it's in, where it's like, I don't know what any of these variables are. I mean, a couple I know, like, okay, temperature and the actual date time, but I have no idea what like num references or DT references or any of this, like this dimension stuff references. So a lot of times when you're just porting data from like, this is data from the ICON mission, the NASA mission that I'm working on for my research right now. But as you can see, it doesn't make much sense in this form. So what our job is to do a lot of times, and you're going to do through your final project, is to find data like this and make something useful out of it and draw cool conclusions out of it. Cool. So let's do this together. I forgot to post this link on Ed, my bad, guys. But if you just look up askthemanager.org and you pull up this little survey, just go on Google, look up askthemanager.org, how much money do you make survey, and hit that the little link that says this link. Oh, wait, no, not this link.
The view
all responses in a sortable spreadsheet. So everyone take a second to do that. Hopefully it comes up. If not, it's up right here. So this is an example of a live data set that's on the internet. Someone put a little Google form on the internet and is just collecting data from random people about what they're up to, I guess, in the general day-to-day of their life. And so what I want y'all to do is take a second to look through the data frame. As you can see, we've got a bunch of columns of data, and I think quite a few of these variables are like free text in like entry. Like a lot of people didn't put any data here, and then one person like wrote a sentence. And you can see just like in general, these are all There's some categorical variables where it's like people clearly pick woman or man or what type of degree they have. But in other categories, you have like varying responses. So the first thing I want to do is take a minute, look through this data set with the people around you and come up with 3 ideas. It doesn't have to be 3. Come up with a couple of ideas on how we can make this data more readable or usable or standardize it or something like that. Yeah, take a second, talk to people around you. If anyone has an idea, just literally yell it out. There's no bad ideas.
Go back. Pie chart.
Pie chart. What would you put in the pie chart?
Say one for like each. So like, what location people are answering the survey from, I see a big chunk from the US, somewhere from the UK.
Definitely. Visualization that'll tell us things. Okay. Cool. Once people show up and talk about your suggestions.
Oh, wait, and then,
Are people able to find the link? It's also okay if not, because it's up here, but it should be easy to find.
yeah. Yeah. I think it's the most likely thing to do is simple work. Then you can create that as a variable.
Okay.
Yeah.
Here's some conversation.
Very. Like,
Yeah. Okay, so what I asked you to do is look through the data, come up with some ideas on how we could use it, what questions we can answer. I got one idea from the front where we were talking about like, you see how people are potentially answering from different states or countries, different countries, so you can make a pie chart to visualize where all these responses are coming from. Any other ideas of like things we could do with this data, what we could do? Yep.
Scatter plotted like age versus salary.
So something that we could look at is age versus salary, according to what range of ages you're in, how much are you approximately making? I do want to point out something with that though. All the salaries are put in these numbers, right? But do you see how there's an other column here that's like, please indicate what type of currency? So if we were to do a scatter plot like that, we wouldn't have a standardized data set. So first we'd have to figure out how to convert all of the currencies into a certain specific currency, and then we could do a plot like that. So when you're looking at data sets, you want to make sure that you like look at the units, look at what exactly like everything means, which might be complicated. I think this is a relatively understandable data set, which is why I'm using this as an example, but make sure we're careful with what we're looking at. Any other ideas? Anything else? Doesn't have to be super complicated. Okay. Yeah, I mean, some things that I noted down were converting all the currency to one same like standardized like currency, and then seeing how the industry you work in or the age you are affects your starting salary or what salary you're getting. So that's one example of a question that we could ask about this data set. Cool. Let me go back.
Okay.
Okay, so lovely.
Cool.
So the process that we just very, very briefly walked through is something called exploratory data analysis. If you ever take a data science class at Berkeley, they'll love throwing this word at you, and it sounds like a lot, but it's literally not. It's just look at data and identify what we can do with it. It's a process that works basically everywhere in the world. Anytime we have to use data, a lot of people will say it, a lot of data people will say it. But in general, it's just finding cool data and trying to answer questions. Because we have a lot of data today.
All right. So now we're going to do a little bit of work with a package called Pandas. Pandas is just a tool for us to process data, display data, look at data. Its name is not like the animal pandas. It's derived from panel data. It's a library to make data cleaning and analysis fast and convenient in Python. And it adopts a lot of like similarities from NumPy. But the biggest difference is that Pandas is designed for working with like table data rather than like lists or numbers. So we're mostly going to be looking at different types of data structures in pandas. So there's three main types of data structures in pandas. We have a series, which is you can think of like as array, as an array. It's like a 1D labeled array, like one column of data. Another type is a data frame. Just think about it like a table, like in Excel or something. And then there's the index, which is how we're able to access different elements of the data structures. So yeah, so we're gonna hop into a demo. I have you guys open up Jupyter notebooks. They did Jupyter, right? They already done it.
To Jupyter, right? Is everyone on Jupyter?
Yes.
Cool. Okay, so
Nobody use VS Code for any.
yeah,
Please. Heavily recommended. Start using Jupyter.
yes. So can everyone see this, or do you want me to? I'll zoom a little bit.
Yes.
There we go. Okay, so everyone, go ahead and open up a new Jupyter notebook. And the first thing we're going to do is just import some packages that we want to use. I'll give everyone a second to. Can I get like a thumbs up if people have Jupyter notebooks open right now and like a new thing open? Okay, we'll give it a couple more seconds. Okay, computers do that.
Also, like, don't feel super like pressured to like code out this demo as we're going. Will and I will upload everything that we have on here onto the course right after.
Just make a new notebook.
Just make a new notebook.
Make a new notebook. Do it from scratch.
Yeah. Okay, so like I said, the first thing that we want to do is import a couple packages. We've done that before with NumPy. So we're gonna tell the notebook to import pandas as PD. That's just what we're gonna use as a shortcut for pandas because we don't want to write out pandas every time. We're also gonna import NumPy because we're gonna do a little bit of work with NumPy. And then also this thing, it'll be important later. We don't really use it that much, but it's for another data set. So just copy exactly what this says. And then just like look up generally if you guys have all these packages imported.
You don't need to worry about what stats model API is. It's just a way for me to later in the lecture use a data set straight from the internet instead of having you guys download it and re-upload it. That's it.
Yeah.
Oh, that's just a comment at the top. Your import packages is just saying.
Oh,
that's
yeah.
what we're doing.
Yeah, that's just anything with a hashtag is just a comment. It's not code.
Just like a text comment so I can tell y'all what we're doing.
Okay. So it looks like everyone sort of has it ready. So very important, make sure you run this cell. Otherwise, the rest of the notebook is not going to know what PD is or what NP is later on. So just run the cell so it recognizes those names. You can either hit run up here. I think you guys all know that, or shift enter if you don't know. But we're going to move on to actually creating data frames using pandas. So there's three main methods to creating data frames. The first two aren't as common, but we're going to cover them anyway. The first way is from making a data frame from scratch using an array or using arrays. So there's this call to a method pd.dataframe. We're basically telling pandas, hey, I want to make a data frame. And then we specify, we make an array of arrays. So it's going to be the first element is the array 1, 2, 3, 4, 5, 6, 7, 8, 9. And each of these are going to be the elements in a column. So here, I'll just run it to show you guys what it looks like. So as you can see, it's a table. And then we specify the column names saying columns equals, and then in a list of whatever we want the column names to be. So you can see that the first column is A, and it has the elements 1, 4, and 7. The second column is B, has the elements 2, 5, 8. And then the third column is C, has the elements 3, 6, 9. So basically, these are the column headers, and then each of these are like rows in a table. So this isn't super common because oftentimes we're working with larger data sets, but we're just showing you guys how to do that. Is there any questions about this, or can we move on? Okay, I'm just going to move on. So the second method is we can make a data frame from scratch using a dictionary. So with a dictionary, basically the keys are going to be the keys here, fruits, vegetables, and nuts, are going to be the column headers, and then the values in a we want to use a list so that it knows to put each of the values in a list, or values in a column. Each of these values are going to be like the values inside the columns. So for example, under fruits, we have apples, bananas, mangoes, and strawberries. With vegetables, we have carrots, broccoli, Spanish artichokes. You kind of get the idea. So is there any questions about making a data frame from a dictionary?
Just on that note, one important distinction to make between using a dictionary and using arrays. We saw that when we used arrays, each array became a row. When we're using dictionaries, each key value pair becomes a column. So I know that's a little unintuitive, which is why we don't use arrays because they're funky. Usually when you're creating data frames, you'll try to make them out of dictionaries because it's just nice.
Yeah, block layer. Question? Yeah, sure. This one. Got it? Okay, cool. All right, and then any other questions at all? Okay, so now we're going to move on to the last method. And this is sort of uploading another source of data from an existing file. So for example, from a CSV file, and telling Pandas to read it and make a data frame from it. So this is a data set we're going to use in the homework. It's going to be available on B courses later.
It's already available.
Oh yeah, it is. It is already available. I can show you guys how to get there if you want. B courses.
It would also be good for everyone to download this, so it's easier for you on your homework.
Yes, exactly. Let this load. Okay, so if you go to files and then it's in demos, right?
Yes.
Demos, and then Titanic data CSV. If you just hit the three little dots here and hit download, then it'll download to your computer. Important thing is make sure that this file is in the same folder or same general area as your Python notebook. Otherwise, it's not going to know what Titanic data.csv is. It's going to get mad at you. So yeah, I'll give everyone a couple seconds to get that downloaded and onto their computers. So can you guys see?
Go into files and into demos.
Yeah. And then just sort of look up when you guys have that downloaded. Okay, it's okay if you guys don't have it downloaded. We just wanted to show you what you can do with it. So I'm just gonna move on. Don't worry about it too much. We can help you later if you still need help downloading it. Yeah, exactly. So, but basically, so Titanic data is a CSV file as specified by the ending .csv. So we can tell Pandas that it's a CSV file and it can read its contents and basically make a data frame from it with the command pd.readcsv. And then in the input, we just want to specify what the name of the file is that we want to be reading. So when we run this, then we have a really large data set of all the passengers on the Titanic. As you can see, it's really, really big. It's like 890 rows and 12 columns. So that's why we normally load up data sets from other sources. because it'd be really tedious to type in 890 different, like 890 rows and 12 columns. That's like a lot of stuff that it would be really difficult to do by yourself. So yeah. Um, so now we're going to move into a little activity. We want you guys to make a pandas data frame from a dictionary that has some information about you and the people in your group. So we want a column of all your names, a column of all your years, your favorite colors, the song you listened to most recently, and your favorite TV show or movie. So we'll give you guys a couple minutes to talk to each other and then make a dictionary of each other's information and convert it to a data frame. So go and do that. And raise your hands if you have any questions.
We might get the for the data dictionary.
So we want the strings, but otherwise.
Yeah, not yet.
Where did you download your?
But I mean, like, all that stuff.
You know there's most. In your OneDrive, okay, so. Just want to try and move your.
Yeah, I agree.
Because like I said, yeah, it's not the same place. It's like, I don't know what that. So. Yeah.
So far, for rejection.
Oh, okay, so you can. Okay, oh, it's okay, it's okay, it's okay.
Oh, yeah. I did. Favorite seller right now? Okay, yeah.
Okay, it's okay.
Olivia, what's your favorite color? Okay, that's the last person. Okay, you know what? Please, but. Yeah, red is usually my favorite color. Yeah. Oh, my brother. By the big door, so not by against.
Yeah, maybe try red. I don't know.
Yeah.
They're really quick.
Okay.
Yeah, just make sure if you're ever in general stuff and this, and you want to load it from a pictures and see.
Actually, situations pretty clear.
Yeah. Yes, so I assume.
A little bit one song. So they have a. Oh no, I'm sorry. I'm not even everybody. I don't know. Hey, Pastor, right? It's something you're over there. Okay, right now.
From what I understand, I have a good deal compared to most people.
We're doing like a list of the dictionary thing. Sorry, we're really okay. What? Yeah. Okay. Olivia, give me one. Oh, okay, you know what?
You got it.
There we go.
Oh, I see.
There we go.
Yeah.
And
The only
what you
application that you can just.
there, so once you get back to it, syntax thing, we can sort of
Okay, everyone, let's come back together. I guess I'm assuming most of you figured out how to do it, but I'll just make like a quick one just to show you guys what it should look like. So let's say I'll call this dictionary group info. So I'll say Pranati is my group partner. So so our names would be, this is mine, Pranati, and then we want to do years, and then this means like your year in major. Okay. Okay, and you're senior, right? Okay. Senior. And then favorite color. What's your favorite color?
We'll go blue.
Blue. Okay, mine is also blue. So we're gonna have two blues. Okay, and then I'm just gonna stop here, but it's you guys get the idea. So, and then if we call PD dot, or we'll say group EF, we'll say PD dot data frame group info. And then show group EF. There we go. So now we made a little pandas data frame column with the names column, years column, favorite colors column, and all the information as part of those columns. So yeah, if you guys have that, then great job. And then now we're going to move to another demo, right?
Please, let's hop to the slides.
Okay, perfect.
Just so I can like walk through the slides.
Okay.
Hey. Okay, so what we just did. Wait, hold on. No, you're so good. Oh, what? Oh, okay, it is there. I'm silly. Okay, so what we just did was create a data frame from scratch, and we also created one from a CSV file, which was mainly like loading it in. We also showed you how to do that from the dictionary. Now that you have a data frame, a lot of times you want specific data. You want specific rows, specific columns, specific data points. So we're going to show you how to do that. I'll steal your computer for a little bit. Okay, so the way that you can pick rows and columns in Pandas, there's two functions or two methods to do it. One is by using .lock, and the other is by using .ilock. So names sound really funky. I'll make it make sense, don't worry. So .lock is label indexing. It's easy to think of it because L for label, L for lock. And the way that you will use .lock is by using the names of the rows or the columns. So, can you guys see the little sample data frame here relatively clearly? Ish. Okay, cool. So, if you look at this little data frame, you see that there's a list of columns, which is max speed and shield, and you have rows, which are Cobra, Viper, and Sidewinder. So usually you see that, wait, how do I get to the demo? Sorry.
Escape, and then why are you not? And then it is here.
Thank you so much. So, this is just literally me loading in a data set. So don't worry about this code. Also, don't worry about coding any of this part. This will be uploaded. You guys just run it. I just would rather you pay attention here. So I'm creating this or sourcing this data set off the internet. That's a data set of election information. So we can see how there's a bunch of rows and a bunch of columns. Now, I want you guys to note that the leftmost column and the topmost row are in bold. You guys see that, right? And you should see that with your Titanic CSV as well, where you have one of the topmost row and the leftmost column that are in bold. This means these are not rows or columns. These are your indexes. Remember how we talked about earlier in lecture, there's 3 data structures. One is an index. These are your indexes. So you have all of these labels or indexes for your columns, like population, TV news, PID, age, education, et cetera, et cetera. And then you also have labels for your rows, which are 0, 1, 2, 3, and 4, et cetera, et cetera. I know that's confusing because you're like, these are like the index and the label for the row are the same because they're a number. But for the column, if you were trying to access column 0, that's this first column, but it's also the population column. Does that make sense? I know that's a little confusing. We'll see it in this example. So if I'm to use .lock is a label-based slicer, label-based selection process. So when I do that, I need to use the names of the rows or the columns. So if I was just to do .lock of 4, you can also try all of this on your Titanic DF or Titanic data. You could just do that data frame name instead of this. Doesn't matter. But I do my data frame .lock 4, and it says name 4, and it gives me this data type. Can anybody guess what this output is from just by looking at it? And wait, I can scroll back up to the data frame so you guys can see that. Any guesses? So I did .lock of 4, and these are the data points it gave me. And then this was the data frame. Exactly. Wonderful. So .lock 4 gave me all of the data in the row labeled 4. Notice that the row labeled 4 is like also has an integer number 4. I know that's complicated, but it'll make more sense when we do labels with columns because they have names. So when I did .lock 4, it gave me the 4th row. Now, let's say that I also want the 4th row and I want a specific column. The way I can denote that is by saying 4th row. Let's say I want the TV news column. I'm going to do TV news. And that gives me exactly the data point in the 4th row at the TV news column. Does this make sense? This structure of rows and columns is something that like y'all might have seen doing like 2D, like when you did your 2D matrices and you had like a row and a column index, same structure. Because it's literally like, what is a table but like a matrix? Like it's all the same thing. So as you can see here, I used the words TV news. I didn't put a number here because if I put a number here, it's going to yell at me. It's going to say key error. There is no key named 0 because there is no column with the name 0. Does this make sense? Yes. Okay. I'll show you another couple of things you can do. So this is if I want to pick a specific data point. You can also create like a slice. So I could go from the rows 4 to 8, and I could get all the data points of TV news that way. I also believe I can do a list of column names. So if I want like a tiny subset of my data, I can maybe do TV news and like age. And so this is just going to give me the TV news and age from the columns, sorry, from the rows labeled 4 to 8. Make sense to everyone? Any questions about .lock? We haven't covered ilock yet. Cool. So the other method is .ilock. ilock is index-based indexing, which sounds weird, but it's basically instead of using the labels of the columns and rows, it's just using their indices from 0 to like the length of the array or the length of the data frame. So if I'm to do elections.df, ilock of 3 to 6, I'm getting 3, 4, 5, which are 3 rows in my elections.df, 3, 4, 5. Because remember, when we do integer indexing, the last element is discluded. Does sound good to people? Okay, so now I'm also getting all of the columns. Let's say that I only want to get the TV news to PID columns. Can anybody shout out what numbers you might put or like where you might put them to just get these 3 rows with the columns from TV news to PID? Any thoughts? Yeah. Yeah. So we see that the TV news column is the first column because we start at the 0 index. So we can say 1, and then we have this is the second, third, fourth, fifth. Notice that that only printed till dole LR. Can anyone tell me why we didn't get the PID column? Yes, because it's not inclusive. So to get the PID column, we actually need to go from 1 to 6. Make sense to everyone? Cool. Yeah, I'm just showing you more examples. This is giving us the 0th row, so row 0, which is here, at I believe the 7th column, which is education, so it's printing out a 3. Does this make sense to people? How to get a certain row and column or get a certain subset of a data frame? We chilling with that? Okay, cool. Something you can also do that's sometimes really helpful is you can create like a new data frame that is like a tinier subset of your old data frame. So for example, let's say I only wanted this data. Like I only wanted rows 4 to 8 and I only wanted TV news and age. And that's all. I don't want to deal with any of the rest of my data. I can save this to a new data frame called new DF. And I can just like proceed from there because that's my new data frame. And then I can just continue with my analysis from there. Sometimes you just don't want certain data points that are like columns that are irrelevant to your analysis. So you can either do it by selecting the columns you want, or later, I think on Thursday, we'll show you how to use other functions that'll let you like drop columns and do other fun stuff. Cool. And then the last form of indexing, which is a little bit more like casual, like not casual, but it's like a little more, you can't be as specific as you are with iLock and lock, is by just using square brackets, which is what we're used to when we do like an array index. So let's say I just want the age column. I can just do elections df at age. Note, this only works with columns. You cannot access a row like this. So if I were to try to get like row 0, that's going to yell at me because they're like, no, 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 no. There's no 0 in the columns. So this only works with columns and specifically column names. So I can only do like, I don't know, income. Income will work, but no numbers, no nothing, only with column names. Make sense? So those are your 3 indexing methods. I would say that like I personally use .lock the most because to me it's the most intuitive of like I have my bold headers. I'm just going to pick the columns that are in my bold headers. But other methods are also, iLock is also very useful. Sometimes when you're like for looping and you need like to use indexing, like iLock is going to be what you go to. This kind of is most useful if you're just trying to extract one specific column and use it for something. And something that's cool to note is if I check the type of a column, it's going to be a Pandas series. And you know how we talked about earlier, Pandas has a certain like data structure for an array of numbers, like a NumPy array, but it's called a Pandas series. Also, sometimes if you guys have type errors, something that's useful is just using the type function. It'll tell you what type your data is. Cool. Any questions about any of this? Are we feeling okay? This is kind of our basics of pandas, and we'll get into a lot more things next class. Wait, I'm sorry. I'm like actually. Thank you. Oh, wonderful. Yeah, cool. So all these slides will be uploaded, but this is just another example of .lock and .ilock and everything I just showed you. That's it. We have a short lecture today. So if you guys have any questions, feel free to hang out. We're here for the next 10 minutes. And then there's office hours right after in the other room. Question? Yes. Yeah. I'll basically, as soon as I stop this, I'm going to just upload it from my computer across. Yeah. Okay. Cool. Leave early if you guys have nothing to do. Take 10 extra minutes. If you want to end the recording and do all the things. Thank you. What's up?